Okay, welcome to a session on forensics investigations on internet browsers. And what I'd like to do today is give a little bit of an overview of web browser history. Let's have a look at some popular browsers that you might come across, how to access browser history, how the cache of a browser works, what cookies are, how they're used, and there's a little bit at the very end about private browsing. So let's start off with what a browser is. A browser is essentially a HTTP client, and their purpose is to use the HTTP protocol in order to get documents from a remote server, and then however those documents are passed to the browser, they then have to render them on the user's computer. Now, almost always that rendering is going to be specified in something called HTML. And a lot of students get confused between HTTP and HTML. HTML is your markup language that specifies how information is going to be displayed on your computer, and HTTP is a protocol that controls how information is transferred from a server to your browser, and perhaps from your browser to the server. Now, there are a set of browsers that you should be aware of. The very first one, as we happen to be on a Windows system, is Internet Explorer. It is bundled with Windows. As we saw with the registry, it's quite tightly integrated into the Windows system. Gareth has written here that compliance with standards is flaky. I've heard that from other people as well. And then we have Mozilla Firefox, which used to be quite popular. Is largely being overtaken by Google Chrome. And then a couple of other browsers that you see at the very end there, something called Opera, and then something called Safari, which you may find exist on a system depending on what sort of system you're looking at. I believe my next slide has a look at the usage share of browsers up to around about halfway through 2014. And as you can see here, the use of Internet Explorer has actually gone downwards quite dramatically. The use of Firefox is relatively stable, and the use of Chrome has gone up quite dramatically. And also the use of mobile has gone up as well. Now, what this sort of says to you probably is, okay, Chrome is quite heavily used, however, historically Internet Explorer was. So it's good to know some of the interesting things that Internet Explorer does and that Windows does in tying Internet Explorer to the Windows system. Now, let's start off with Internet Explorer. Internet Explorer has something called an index.dat file. It is a proprietary file format, and it is there only for storing IE history. You can extract information from it as long as you have an idea about how to do some reverse engineering. And what we do know is it contains some form of a hash table, it contains a set of activity records, it stores some HTTP headers, and it is possible from this index.dat file to detect deleted records. Now, we have some examples of this opened up in a hex editor. Here is some information about the record format. We can see we have something that's highlighted here, the last time the web page server was modified and the last time this was actually accessed by the user. This we can view as the index.dat file in a hex editor or a hex viewer, and as you can see here, we're able to extract ASCII encoded information. And so a couple of pieces of ASCII encoded information that are mildly interesting is the fact that we're able to extract the text URL. We're also able to extract the URI, the identifier of the website that we want to visit. And it looks like we're visiting something called www.ethereal.com, Ethereal being the precursor to Wireshark. So wherever this was captured from, it's from a few years back. We then also have some other information, and we just don't know this because it happens to be encoded. We have the last access timestamp that happens to be located, and Gareth has just given you the location of this timestamp that can then of course be decoded if you happen to have a parser of your index.dat file. And here is the output from well, backtrack 5, precursor to Kali. Here is a parser of the index.dat file, which gives us an idea. So this parser has actually been able to decode some of this date and time information, and it's been able to decode some of the information that is being transmitted, such as what websites were being used, what URIs were being accessed, which is interesting to us from a forensic point of view. I think some of the questions you'll be asked will be about what websites have been visited and when. Now, in addition to this, we also have associated with all web browsers something called a cache. Now, your cache file is a way that you're going to be able to, is something that your browser will use in order to store frequently used objects. So your cache file might store images, large images. It will store things like the Google logos. It doesn't make sense to load the Google logo every time. But your browser will also store things like videos, images, JSON files in the cache folder. And that means that it contains a wealth of information for a forensic investigator. For those of you who were doing my unit last year, the digital forensics unit, I asked you to look at the browser cache on the system that we're working on, and in that browser cache you were able to extract image files. I believe some of you extracted some sound files, and some of you were able to find some video files as well. However, they weren't labeled very easily. We actually had to go through and use a tool called EXIF tool in order to find those. Now, the items that are stored in the cache, well, how long are they stored for? Web servers themselves, so where you're getting this information from, will often specify the expiry time of the information that is stored here. And the cache also has a limited storage capacity, although this is actually normally configurable. So it may be that items are only stored in the cache for a very short period of time. It may be that they're stored for much longer. You may also find some special files that Gareth has identified as being JPEG, GIFs, HTML, JSON, and Gareth has particularly identified this because Facebook chat messages are exchanged using JSON between the user page and the server, and that means that if you see some standard URIs and a standard URI given here, it may be that you're able to extract some JSON associated with the message that is being transmitted. And I believe we have some examples here in a sec. Just before we go there, let's have a quick review of JSON. So JSON is a JavaScript object notation. You don't have to be using JavaScript in order to use a JSON format. So it's very easy to see how this is formatted. We have over to the left here some variable names, and then we have some values for those variables. So we can see that we have what could be considered to be a number, and then we have what could be considered to be an array of characters, a string, and we have what may be an array of strings here, and we also have the ability to have a variable that is defined as a structure. So within this variable we have two other variables that store different things. So JSON is a very standard way of formatting data and transmitting that data between computer systems or between applications. And it may be that you find some JSON information that you are then able to interpret from the cache or from anywhere else on a computer system. So what can we learn from cache? Well, we're not able to extract stuff like PHP code, of course, because PHP is something that's referred to as being a server-side technology, and that means that your PHP code will actually be passed and will generate HTML code that is then sent to the client. So we never actually see any PHP code. We might see some pre-computed data from the server, like complete profile pages, pages with comments on, times they're visiting, and it may give us the ability to see information that the server has sent to the computer system. So a window into the past, as Gareth says here. Now, the next example is actually something that's been captured from RAM. So we have a Facebook comment that's extracted from RAM and browser cache in HTML format, and a Facebook comment that's extracted from RAM and JSON format. And what we can see here is, okay, there's a whole lot of information that we're able to see. There's lots of HTML information, and then we see something that is, okay, here's our very nice user.php ID, and then we see some information that is passed using JSON, and it's a comment. And we're also able to extract information directly from memory. So this is information, of course, for this HTML page to be rendered, it must be stored in memory to be processed by the browser. And we're also able to extract JSON information from there and get more information about the browser. Now, in order for the browser to use websites, the websites may want to know particular things about the user. And so the website may store information about the user's session. It may store information about the user themselves in something called a cookie. And this cookie is actually stored on the client side. So it's information that is stored by the browser. And it may be resent for every HTTP request that is made by the browser to the web server. And the web server will then use this in order to track sessions, aka in order to identify users. It may well use this cookie information in order to store particular preferences that the user has when they're interacting with their website. So it gives the server the ability to get some feedback from the user, and it gives the server the ability, the website, the ability to do some sort of personalization of the services that they're offering to the user through the web browser. I believe we have an example of a cookie here, so you're able to have a look at the cookies through your web browser. You're actually able to see the cookies as well if you happen to be intercepting the web traffic, so you'll be able to see this using Wireshark. You'll be able to see this using something called Burp Suite that intercepts your traffic. And we can see here, okay, well, the content of the cookie, that means absolutely nothing. We can see what domain this is associated with. We can see when it was created. We can see when this cookie expires. So this cookie is due to exist on this system for 2 years, which is quite a long time. Now, of course, if you have cookies that are associated with the browser, it gives you an idea about what sites a user has visited. It gives you an idea about what sites perhaps the site the user has visited is linked to. And it may be that you're able to extract tokens from the cookie, session IDs, and it may be that you're able to use those session IDs in order to hijack a session that a user had established, an authenticated session that a user had established with a remote website. We then move on to a private browsing. Okay, so we've just looked at, Internet Explorer gives you lots of information in the index.dat file about history. It stores lots of information on the cache. Now, lots of people don't want their web browser to do that, and so web browsers have established something called private browsing, which means that your history is not recorded and nothing goes into the cache. Now, private browsing is supported by most modern browsers for quite a long time now, and the idea is it leaves no trace on the computer about what the user does. However, plugins may still leave a trace as the browser does not control them, and that is quite important to note. And websites, of course, how the websites that you're accessing may still record what you've done. So it may be that your Google search history, it may be that what you're doing on a remote website is recorded by that remote website, and that remote website may pass that information back to your computer through normal interactions. Now, here's an example of, I have a feeling that this is Firefox. No, Google Chrome. You have gone incognito. So this is the private window that's Gareth has put in for private browsing incognito mode in Google Chrome. Now, there's also interesting set of statistics for the observed rates of private browsing use. These are split into 3 categories: reading news, gift shopping, and accessing adult websites. And adult websites seems to be quite dominant in people's use of private browsing. As we can see there, you may be able to well, you can make some sarcastic comments about people who use Safari, can't you? Google Chrome and Firefox. Well, they're slightly different to Internet Explorer. They do still have a history file. It's stored in SQLite format, and so all that you need, you can use standard SQL in order to query this database. You just need to get access to the database file, and then you're able to query it in exactly the same way you can parse the index.dat file of your Internet Explorer. The cache directory for Chrome happens to be stored. Some files are compressed. It may be you need to look at the header in order to identify what the files are and whether or not they need compressing. And if they're compressed, it may be that the header gives you an idea about what compression algorithm is being used, which enables you to decompress them. So, as some conclusions for this presentation, the cache is the file store. Whose purpose is to reduce network traffic. However, cache is also a great way to see what files have been rendered by your web browser, which may give you an idea about what websites that user has accessed. Cookies are a piece of information that are used by a website about the user and the user's preferences or the user authentication. These are also stored in the browser. And Chrome and Firefox use SQLite databases extensively, and therefore it's recommended that you become familiar with SQLite databases. Okay, thank you very much.